In the first video, we talked about the node editor for the Materials tab. In this video, we're going to talk about how to use geometry nodes to customize the appearance of some PLY cloud data. Download loc_0016 if you would like to follow along. On the right side of the screen, there is a panel with many tabs. The orange square tab gives you object coordinates and rotation. To put our object on its side instead of standing up, I've rotated it in the Z and Y directions by 90 degrees each. Navigate to the Geometry Nodes tab and press the New button at the top of the node editor. We are given a simple node configuration where the input from the PLY file is directly connected to the output in our Blender scene. Add a new node using the Add button and search for Mesh to Points. If we drag this node onto the existing line between our input and output, we will be able to modify the geometry. The next step can help if your computer doesn't have a strong processor. Drag in a random value node and change the first option from float to integer. Set them with a minimum of 1 and a maximum of 5. Next, add a compare node and choose the second drop-down to be less than or equal. Attach the pink result output of the compare node to the pink selection input on the Mesh to Points node. This means that every point will be assigned a value 1 through 5, and we only include the ones that have a value of 1. Essentially, this means we only get to see 1/5 of the points. If later on we decide we want more points, we can change 5 to a lower number, or if we disconnect it altogether, we will have all of the points again. I will next explain 3 different ways to model a point cloud. Here is the first and most simple. After Mesh to Points, we want to include a node called Instance on Points. Add another node labeled Cube. Instead of changing all 3 side lengths directly, we can connect a value node which will apply to all 3 dimensions. Connect the output of Cube to the input labeled Instance. Notice how every point becomes a cube. The second way of modeling works best for many points that act like a fluid body. After the Mesh to Points node, substitute in the Points to Volume node. Let's set a radius of 0.05 and our voxel amount to something high, like 2000. If we then put in a Volume to Mesh node, we can see each particle as its own little droplet. If we also include the Set Shade Smooth node, the object begins to look more like a fluid. You can also change the settings of the Volume to Mesh node to be more high resolution. Finally, you might want to change the appearance of each cube based on the individual particle properties. The ones in this file are position, emission, size factor, color, and opacity. We can access any of these with the Named Attribute node. By plugging our size factor into Scale, we can have the biggest particles actually look bigger. However, some of our particles have a size factor of 0, so we can add a Math node to slightly alter these values. I will use the Add node so that each particle is at least 0.25 units big. At the end, we can use the Realize Instances node so that we can also set material. In Blender, geometry nodes and material nodes are able to communicate via named attributes. This might be physical location, color, or custom attributes like emission. Let's go to the materials nodes and create a new material. We can change the color of all the points manually, as we would any object, or we can use an attribute node to set the color based on geometric properties. Make sure that you spell the attribute exactly the same as in geometry nodes. Now we can see that the biggest particles are pink and the smallest particles are blue and yellow. To change emission, it's important to know that there are two emission input nodes for a material. The first is for emission color and the second for emission strength. We will set emission color to be the same as particle color by connecting the color output node to the emission color input node. We will create a new node for the emission attribute and connect it to the emission strength input socket. Sometimes, point values from geometry nodes might be too big. We will use a color ramp to normalize these values. The black on the left represents 0 emission, and the white on the right represents maximum emission, which in this case is a value of 1. We can move the black and white sliders until we like our final result.